Hello, in this lecture we will find the radius of the semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle because angle ABC is a right angle, it equals to 90 degrees. So here we have angle ABC, that is a right angle. And also side AB of triangle ABC equals to 3 units, and side AB of triangle ABC also is tangent to the semicircle at point B, and also line segment AE is tangent to the semicircle at point E. And we also know that line segment DC equals to 1 unit, and inside the right triangle we have a semicircle, and we want to find out the radius of this semicircle. So first of all, I will present to you a new rule. Rule number 1, or two tangents theorem. Two tangents theorem states that rule number 1, or two tangents theorem, so two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 1, or two tangents theorem again. According to two tangents theorem, the lengths of two tangents from a common external point to the circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and we also have an external point, point P. This point P, is an external point to this circle, why point P is an external point? Because point P is not located inside this circle, nor on this circle, therefore point P is defined as external point to this circle. And if from point P we will draw two tangents to this circle, so the first tangent will be this tangent, and the touching point between the first tangent and the circle will be defined as point A. And we will draw also the second tangent to this circle. The second tangent to this circle will be this tangent, and the touching point between the second tangent and the blue circle will be defined as point B. Actually, the length of the first tangent is PA, and the length of the second tangent is PB, and according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. Okay, that is actually the two tangents theorem. Two tangents theorem states that whenever you draw from an external point to a circle two tangents to that circle, then the lengths of those two tangents will be equal to each other. So the length of the first tangent is PA, the length of the second tangent is PB, and the lengths are equal to each other. That is to say, PA is equal to PB. Okay, so if you have an external point to a circle, and from the external point of a circle you draw two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, so that is actually the meaning of rule number 1, or two tangents theorem. And we actually can implement the rule number 1 in our drawing, because in our drawing we have point A. Point A is an external point to this semicircle, and from point A we have two tangents to this circle. The first tangent is tangent AB. Tangent AB is tangent to the semicircle as point B. So the first tangent is tangent AB, and the length of the first tangent is AB, that is equals to 3 units, and the second tangent to the semicircle as tangent AE is tangent to the circle at point E, and the length of the second tangent is AE, and according to rule number 1, the lengths of two tangents from an external point of a circle are equal to each other. That is to say, AB equals to AE. Because of the fact that from the external point A we have two tangents to a circle, the length of those two tangents will be equal to each other. That is to say, AB equals to AE. But we know that AB equals to 3 units. It is given us in the question. Okay, so from this equality we will derive that AE also equals to 3 units. AE equals to 3 units. Okay. In the next step, I will present to you a new rule, rule number 2. According to rule number 2, or rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that actually if you have a circle, suppose that you have a circle and the center of this circle is at this point will be defined as point O, and we also have tangent actually tangent AB in the red color is tangent to the blue circle. At this point we will define the touching point between tangent AB and the blue circle as point M. Point M is also defined as the point of tangency of tangent AB with the blue circle. So point M is the point of tangency of tangent AB with the blue circle, and if from the center of the circle, that is to say from point O, we will draw radius to this circle that touches the circle at point M. So OM is the radius of this circle. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its points of tangency. This radius OM, is drawn to the point of tangency, that is to say, is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius, that is to say, this angle is a right angle, it equals to 90 degrees, and this angle, it is also a right angle that equals to 90 degrees. Okay, so according to rule number 2, whenever you have a radius that is drawn to the point of tangency, like in this drawing, we have the radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so actually we can implement rule number 2 in our drawing, because first of all, we will define the center of this semicircle as point O. Again, point O, this point is the center of the semicircle, and we will join together points O and E by a straight line. Actually, line segment OE, this line segment is the radius of the semicircle because of the fact that line segment OE starts from point O, that is the center of the semicircle, and ends at point E, that is a point on the circle itself. It is a point of the semicircle itself, therefore line segment OE is defined as the radius of the circle, so we will call it R, abbreviation for radius. So OE is the radius of the semicircle, and we actually see in the drawing that the radius OE is drawn to the point of tangency, that is to say, it is drawn to point E. Point E is the point of tangency, of tangent AC with this semicircle. So point E is the point of tangency of tangent AC with this semicircle, and in the drawing we can see that the radius OE, it is drawn to the point of tangency, that is to say, it is drawn to point E. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. Okay, so actually angle OEC equals to 90 degrees. This angle equals to 90 degrees. And if this angle equals to 90 degrees, then triangle OEC will be a right triangle. Okay, so the green triangle, triangle OEC, it is a right triangle because of the fact that angle OEC equals to 90 degrees, it is a right angle. Okay, so we'll focus on this right green triangle. Okay, we will focus on the green right triangle, triangle OEC. So on the green right triangle, triangle OEC, according to the Pythagoras theorem, in the right triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Again, according to the Pythagoras theorem, will repeat again. In the right triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? Actually, the hypotenuse of the green triangle is OC. So the square of the hypotenuse is OC squared equals to the sum of the squares of the perpendiculars equals to OE squared plus EC squared. EC squared. We will define side EC of the green triangle as X, that is to say EC equals to X units in its size. So I'll repeat again that according to the Pythagoras theorem, if we focus on the right green triangle, triangle OEC, OC squared equals to OE squared plus EC squared. Okay, so what is OC? What is the size of OC? Actually, the size of OC, the size of side OC, the size of the hypotenuse. First of all, what is OD? OD is the radius of the semicircle because of the fact that line segment OD starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle. So I will call it R. And we also know that DC equals to 1. So OC equals to OD plus DC. That is to say OC equals to OD, that is R, plus DC, that is 1. So OC equals to R plus 1. And OC squared will be equal to R plus 1 squared. And what is OE? OE is the radius of this semicircle. It equals to R, so OE squared will be equal to R squared plus EC squared. According to our definition, side EC of the right green triangle is X, so EC equals to X, so EC squared will be equal to X squared. So in total we got that R plus 1 squared equals to R squared plus X squared. Here we will open the brackets in this side of equation number 1. R plus 1 squared is actually equals to R squared plus 1 plus 2R, according to the formula that A plus B squared equals to A squared plus B squared plus 2 times AB. So all equals to R squared plus X squared. Okay, so we have this equation number 1. Here we have R squared in this side of equation number 1, and we have R squared on the other side of the equation number 1. So we subtract R squared from equation number 1. So R squared will get cancelled, and what is left after we cancelled R squared? What is left is it is actually 1 plus 2R equals to X squared. Okay, 1 plus 2R equals to X squared. So according to equation number 1, 1 plus 2R equals to X squared. So in the next step, we will focus on the right big triangle, triangle ABC, and we will also focus on the right small green triangle, triangle OEC. Okay, so I will write it down. We'll focus on triangle ABC and triangle OEC. Both of them are right triangles. We'll repeat again. We will focus on the right triangle, triangle ABC, and also on the right small triangle, triangle OEC. Okay, so on those two triangles, those two angles are equal to each other. They are both right angles. So I will write it down. Angle ABC of triangle ABC equals to angle OEC of the green triangle, triangle OEC, and both angles are right angles. They are equal to 90 degrees. Okay, so actually angle ABC equals to angle OEC, and both angles are equal to 90 degrees. And we also have here this angle, I will call it angle C. Angle C is a common angle. It belongs both to the big triangle, triangle ABC, and angle C also belongs to the green triangle. So I write that angle C equals to angle C is a common angle that belongs to both triangles. So angle C equals to angle C is a common angle. Okay, angle C equals to angle C is a common angle, and actually those two angles are equal to each other. I will prove that those two angles are equal to each other. So we will write down that angle BAC, this angle, is equal to this angle, angle EOC, equals to angle EOC of the green triangle, angle EOC. So angle BAC of triangle ABC equals to angle EOC of triangle EOC. And they are equal to each other according to third angle theorem. Okay, they are equal to each other according to third angle theorem. So what is the third angle theorem? Actually, third angle theorem states that, or rule number 3 of third angle theorem, so according to rule number 3 or third angle theorem. If two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I'll repeat on rule number 3 or on third angle theorem again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I read it again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 or third angle theorem? The meaning of third angle theorem is that if you have two triangles, triangle ABC so this is triangle ABC, and we know that this angle is alpha, this angle is beta, and this angle is gamma, and we also have another triangle, triangle DEF, this is triangle DEF, and this angle is alpha, this angle is beta, and this angle is theta. Okay, so actually we have two triangles with two angles that are equal to each other. Two pairs of angles are equal to each other. Those two angles are equal to alpha, and these two angles are equal to beta. Okay, and according to third angle theorem, the third pair of angles also must be equal to each other. That is to say, angle gamma equals to angle theta. According to third angle theorem, angle gamma is equal to angle theta. That is the claim of third angle theorem, that if you have two pairs of angles that are equal to each other in two triangles, then the third pair of angles, that is to say gamma and theta, must be also equal to each other. So we will prove the third angle theorem. Actually, as you already know, the sum of the angles in any triangle equals to 180 degrees. Okay, and especially the sum of the angles in triangle ABC must be equal to 180 degrees. That is to say, alpha plus beta plus gamma must be equal to 180 degrees. Okay? According to the rule that the sum of the angles in any triangle equals to 180 degrees, the sum of the angles in triangle ABC must be equal to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. So that is the sum of the angles in triangle ABC. Okay? And the sum of the angles in triangle DEF must be also equal to 180 degrees. That is to say, alpha plus beta plus theta must be equal to 180 degrees. Okay? In triangle DEF also the sum of the angles must be equal to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. So in the next step we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees is 0. Here we will add to equation number 3 theta, and we will arrive to the equality that gamma equals to theta. So we found out that gamma equals to theta. We actually proved that if we have two triangles that has two pairs of angles that are equal to each other, then the third pair of angles must be also equal to each other. That is to say, we proved that angle gamma equals to angle theta. Therefore, we proved that the third angle theorem is true. So we return to our drawing. So in total we proved that three angles of triangle ABC are equal to three angles of the green triangle, triangle OEC. So therefore we actually proved that triangle ABC is similar to triangle OEC. Triangle ABC is similar to triangle OEC according to angle similarity rule. I'll repeat again. We actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you have one triangle that has three angles that are equal to three angles of the other triangle, then you prove that those two triangles similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to a triangle OEC, the green triangle, we will conclude that AB over AC equals to OE over OC. I will repeat again. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC equals to OE over OC. Okay? But what is the value of AB? AB equals to 3 units according to what is given as the question. What is the value of AC? AC equals to 3 plus X. Again, AC equals to 3 plus X. So, here AB equals to 3 and AC equals to 3 plus X, and all equals to OE. What is the value of OE? OE equals to R, the radius of the semicircle. And what is the value of OC? OC equals to R plus 1. Again, OC equals to R plus 1. So, in total, we found out that according to equation number 2, 3 over 3 plus X equals to R over R plus 1. So here we will cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus X. Okay? Because multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Here we will open the brackets of equation number 2, and we will get that three R plus 3 equals to 3R plus Rx. Okay, so we got this equation number 2. So we will subtract 3R from equation number 2. So 3R will get cancelled. And what is left after we cancel 3R? What is left? It is actually 3 equals to Rx. 3 equals to Rx. Here we will divide equation number 2 by x, and we will get that R equals to 3 over x. So, first of all, why it is allowable to divide equation number 2 by x? Maybe x is 0. And if x is 0, you are not allowed to divide anything by 0. But as you can see from the drawing, x is side EC of the green triangle, triangle OEC. Therefore, it must be a positive number. it can never be 0. Therefore, it is allowable to divide equation number 2 by x. So we found out that the radius of the semicircle equals to r over x. Okay, and actually we have already found out that according to equation number 1, that 1 plus 2r equals to x squared. Okay, so here we can substitute r in equation number 1 by 3 plus x from equation number 2, because according to equation number 2, r equals to 3 over x. So we substitute r in equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. Okay, so we get that one plus 2 r, and r according to equation number 1 is 3 over x, and it equals to x squared. Here 2 times 3 is 6, so we write it down. One plus 6 over x equals to x squared. So that's what we got here. That's 1 plus 6 over x equals to x squared. So here we will multiply equation number 1 by x, and we will get that x plus 6 equals to x squared times x is x cubed. So here we will subtract x from equation number 1, and we will get that x squared minus x equals to 6. We will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. Here we will add to equation number 1 2x squared, and then we will subtract 2x squared. Okay, minus 2x squared plus 2x squared equals to 0. So therefore it is allowable to subtract 2x squared and add 2x squared to equation number 1, because it is like we add 0 to equation number 1. So this operation is allowable. So we will get that x squared minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Okay, then we know that minus x equals to minus 4x plus 3x, again minus x equals to minus 4x plus 3x, so we'll substitute minus x in equation number 1 by minus 4x plus 3x, and we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we write down minus 4x plus 3x, and minus 6 equals to 0. Okay, so we got this expression after we substituted minus x by minus 4x plus 3x. We got this expression, and here we have the expression that x squared minus 2x squared. Actually, we will take a common factor from expression number 1, expression number 2, and expression number 3. Here, from expression number 1, we have x squared minus 2x squared. We will take a common factor of x squared, and if we took a common factor from x cubed minus 2x squared, if we took a common factor of x squared, what we will get inside the brackets? Inside the brackets, from x cubed we will get x, and what is left from 2x squared after we took a common factor of x squared, what is left is it is actually minus 2. And you also have the second expressions. The second expressions is 2x squared minus 4x. So here we'll take out a common factor of 2x. So what is left from 2x squared after we took a common factor of 2x? Inside the brackets, what is left, it is actually x. And what is left from minus 4x after we took 2x as a common factor, what is left, it is actually minus 2. And then we will take a common factor from expressions 3x minus 6. We will take a common factor of 3, and what is left after we took a common factor of 3 from 3x, what is left, it is actually x. And what is left from minus 6 after we took a common factor of 3, what is left, it is actually minus 2. So in total, we actually got those two expressions. So we substitute equation number 1 we'll substitute equation number 1 by those three expressions that are equal to the original expressions. Okay, and we will get that according to equation number 1, x squared times x minus 2 plus 2x times x minus 2 plus 3 times x minus 2 equals to 0. Okay, so actually here we will take x minus 2 as a common factor of those three expressions, and we will get that x minus 2 so x minus 2 is a common factor of those three expressions. So inside the brackets, if we take x minus 2 as a common factor, what is left from this expression? What is left, it is actually x squared. And what is left from this expression after we took a common factor of x minus 2, what is left from this expression, it is actually 2x. And what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually 3. So in total, we got this expression, x minus 2 times x squared plus 2x plus 3 equals to 0. So here we have two solutions possible from equation number 1. The first solution will be that x minus 2 equals to 0, and the second solution will be that this expression will be equal to 0, that is to say x squared plus 2x plus 3 equals to 0. Okay, so we write down those two solutions to equation number 1. So the first solution is that x minus 2 equals to 0, and the second solution to equation number 1, that x squared plus 2x plus 3 equals to 0. So we will focus on the second solution, solution number 2. And this is actually a quadratic equation, and the general formula for a quadratic equation is that ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. The formula for x, in order to find out the value of x, is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay? And in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, we know that a equals to 1, b equals to 2, and c equals to 3. Okay, so we will put the data inside this equation for x in order to find out the value of x in our specific quadratic equation. So here x will be equal to minus b equals to 2, so minus b will be equal to minus 2 plus minus root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times A is 1, so minus 4 times 1, minus 4 times 1 times C is 3, times 3, over 2A. A is 1, so 2 times 1 is 2, so we got this equality. So here x equals to minus 2 plus minus the root of, here 4 times 3 is 12, and so I write it down, 4 minus 12 over 2, so x equals to minus 2 plus minus the root of 4 minus 12 is minus 8. Minus 8 over 2. Okay, so we got this expression, and because of the fact that a negative number doesn't have a root, so there is no solution to this quadratic equation, therefore we'll cancel this option. This is not a correct solution, and we left only with the solution that x minus 2 equals to 0. Okay, x minus 2 equals to 0 is the solution for our two equations. X minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. And we have already found out, according to equation number 2, that r equals to 3 over x. According to equation number 2, r equals to 3 over x. Okay, according to equation number 2, r equals to 3 over x. So we will substitute x by 2 because x equals to 2. And we will get that the radius of the semicircle r equals to 3 over 2 units, or it equals also to 1.5 units. So we actually found out that the radius of this semicircle equals to either 3 over 2 units or it equals to 1.5 units. I repeat again, the radius of this semicircle equals to either 3 over 2 units or it equals to 1.5 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle, and we have here right triangle ABC. Angle ABC equals to 90 degrees. It is a right angle. AB equals to 3 units. Line segment CD equals to 1 unit. And inside the triangle we have a semicircle that is blocked by the triangle. Side AB is tangent to to the semicircle at point B, and line segment AE is tangent to the circle at point E. And we want to find out the radius of this semicircle. So, in the first step, I presented to you rule number 1. According to rule number 1 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. I'll repeat again, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of two tangent theorem? The meaning of two tangent theorem is that if you have this circle and we have external point P of this circle, and from the external point P we will draw two tangents, tangent PA and tangent PB. The lengths of those two tangents will be equal to each other, that is to say PA equals to PB. So whenever you draw two tangents to a circle from an external point of that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, actually we implemented rule number 2 in our drawing. Here we have external point A of the semicircle. Point A is external point in relation to the semicircle because it is not located inside the semicircle nor on the semicircle. Therefore point A is external point of this semicircle, and from point A we have two tangents to the semicircle. The first tangent is tangent AB and the second tangent is tangent AE. According to rule number 1 of two tangents theorem, the lengths of those two tangents are equal to each other, that is to say AB equals to AE. Okay? Because whenever you draw two tangents from an external point of a circle to the circle, the lengths of those two tangents will be equal to each other, that is to say AB equals to AE. But we know that AB equals to 3 units. It is given us the question. So from this equality we will derive that AE equals to 3 units. So we found out that AE equals to 3 units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. I'll repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and the center of the blue circle is at point O, and we have tangent AB. Tangent AB is tangent to this blue circle at point M, or point M is the point of tangency of tangent AB with the blue circle. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to a radius drawn to its point of tangency. So as you can see from the drawing, tangent radius, this radius is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to that radius. So here we have the radius OM that is drawn to the point of tangency, that is to say it is drawn to point M, therefore the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we actually implemented rule number 2 in our drawing, because in our drawing we have tangent AC is tangent to the semicircle at point E. Point E is the point of tangency, and we have this radius that is drawn to the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So, and because of the fact that this angle equals to 90 degrees, then the green triangle is a right triangle. So we focus on the right green triangle, triangle OEC, and on triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. And so what is the value of OC? As you can see from the drawing, the value of OC, it is actually R plus 1. So OC square will be equal to R plus 1 square. What is the value of OE? OE equals to R, and therefore OE square will be equal to R square. And what is the value of EC? The value of EC is X according to our definition, so EC square will be equal to X square. Okay, in total we got that R plus 1 square equals to R square plus X square. We open the brackets in this side of equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R, and all equals to R square plus X square. We subtracted R square from equation number 1, and we got that 1 plus R equals to X square. So we have this equation, that equation number 1, that states that 1 plus R equals to X square. Okay, then we focused on the right big triangle, triangle ABC, and on the right small green triangle, triangle OEC. On those two triangles, we have those two angles that are equal to each other. They are right angles. So angle ABC is equal to angle OEC, and both of them are equal to 90 degrees. They are right angles. This angle is a common angle. It belongs both to triangle ABC, and this angle also belongs to the green triangle, triangle OEC. Therefore, we can write down that angle C equals to angle C is a common angle that belongs to both triangles, and we actually proved that those two angles are equal to each other. Those two angles are equal to each other according to third angle theorem. So angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of the third angle theorem? The meaning of the third angle theorem is that if you have two triangles that has two pairs of angles that are equal to each other, in this case we have, this is the first pair of angles that are equal in both triangles, and this is the second pair of angles that are equal in both triangles. Therefore, if this is the situation, then the third pair of angles will be also equal to each other, that is to say gamma equals to theta. And we actually proved the third angle theorem. We proved the third angle theorem because we know that we proved it like that we know that the sum of the angles in any triangle equals to 180 degrees, and that is to say the sum of the angles in triangle ABC equals to 180 degrees. That is to say alpha plus beta plus gamma equals to 180 degrees. That is equation number 1. And the sum of the angles in triangle DEF also equals to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. Alpha plus beta plus theta equals to 180 degrees. So we got two equations. We subtracted equation number 1 from equation number 2. Alpha minus alpha is 0. Beta minus beta is 0. And we got that gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we got that gamma minus theta equals to 0. We added theta to equation number 3, and we got that gamma equals to theta. So we actually proved that gamma equals to theta. Gamma equals to theta, that is to say the third pair of angles also equal, or the third pair of angles also congruent. If we have two pairs of angles, 1 and 2 pair of angles that are equal, then the third pair of angles must be also congruent. That is to say gamma equals to theta. So we actually proved that the third angle theorem is true. Okay? And then we return to our triangles, to our drawing. We actually proved that all three angles of the right big triangle, triangle ABC, are equal to all three angles in triangle EOC. Therefore, we proved that triangle ABC is similar to triangle EOC according to angle similarity rule. We proved that triangle ABC is similar to triangle OEC according to angle similarity rule. And from that fact that triangle ABC is similar to triangle OEC, we can derive that AB over AC equals to OE over OC. AB over AC in triangle ABC equals to OE over OC in triangle OEC, because of the fact that triangle ABC is similar to triangle OEC. Okay, and AB equals to 3 units, AC equals to 3 plus X units, AC equals to 3 plus X units, OE equals to R, and OC equals to R plus 1. So in total we got that 3 over X equals to R over R plus 1. Here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Then we open the brackets in equation number 2, and we got that 3R plus 3 equals to 3R plus Rx. Here we subtracted 3R from equation number 2, so 3R will get cancelled. And what is left after we cancelled 3R, what is left, it is actually, this is what is left, 3 equals to Rx. So we divided equation number 2, this equation, by x, and we got that R equals to 3 over x. R equals to 3 over x, but we have already found out according to equation number 1 that according to equation number 1 plus 2R equals to x squared. So we can substitute R in this equation number 1 by 3 over x, that equals to R according to equation number 2. So we substituted R in equation number 1 by 3 over x from equation number 2 here, and we got this equation that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we got that 1 plus 6 over x equals to x squared. We multiplied equation number 1, this equation, by x, and we got that x plus 6 equals to x cubed. Here we subtracted x from equation number 1, and we got that x cubed minus x equals to 6. Then we subtracted 6 from this equation number 1, and we got that x cubed minus x minus 6 equals to 0. Then we subtracted 2x squared, and then we added 2x squared to this equation number 1. Minus 2x squared plus 2x squared is 0, so we added 0 to equation number 1. It is allowable, therefore we did it, and we got this expression x cubed minus 2x squared plus 2x squared that equals to 0 minus x minus 6 equals to 0. Then we subtracted minus x by minus 4x plus 3x, because minus x equals to minus 4x plus 3x, and we got this expression. Then we divided the equation number 1 to 3 parts, and from each part we took out a common factor. From the first part we took a common factor of x squared, and that what is left inside the bracket, what is left is x minus 2. From the second part of equation number 2 we took a common factor of 2x, and what is left inside the bracket is x minus 2. And from the third part of equation number 1 we took a common factor of 3, and what is left inside the bracket is x over 2, x minus 2. So here actually we have x minus 2 as a common factor for equation number 1. So instead of those 3 parts, we substituted them by those 3 expressions that are equal to those 3 parts, and in total we got this expression. So from here we can take a common factor of x minus 2 out of equation number 2, and after we took a common factor of x minus 2 from equation number 1, we got this expression that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we have 2 solutions that are possible for equation number 1. The first solution, that x minus 2 equals to 0. If x minus 2 equals to 0, then 0 times anything equals to 0. And the second solution that is possible is that the quadratic equation equals to 0. If the quadratic equation equals to 0, then 0 times anything equals to 0. So we focused on the second solution, that x squared plus 2x plus 3 equals to 0. We solved this quadratic equation in order to find out the value of x. And the general formula for a quadratic equation is ax squared plus bx equals to 0, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according by using a special formula. This is the special formula that we will use in order to find out the value of x. And in our specific quadratic equation, x squared plus 2x plus 3, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation in order to find out the value of x. So x equals to minus b, b equals to 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a, 4 times a is 1, 4 times 1 times c is 3, so in total this is 4 times 1 times 3. Okay, so we got that x equals to minus 2 plus minus 4 minus 4 times 3 is 12. So it is 4 minus 12. So here we have x equals to minus 2, and inside the root we have 4 minus 12. 4 minus 12 is minus 8. And because of the fact that a negative number doesn't have a root, therefore then there is no solution for this quadratic equation. So this possibility is not correct. And we left only with the solution that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. X equals to 2. And we have already found out that r equals to 3 over x. So we can substitute x by 2 because x equals to 2. We substituted x by 2 in equation number 2, and we found out that the radius of the semicircle equals to 3 over 2 units, or it equals to 1.5 units. I will repeat again. The radius of this semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.